All right. Activity 3.4, practice with probability and percent error. As the number of trials increases, the experimental probability tends to get closer and closer to the theoretical probability. What do you think will happen to the percent error as the number of trials increases? Flip a coin 10 times. Record each measure. The experimental probability of flipping heads versus the theoretical probability of flipping heads. I know the theoretical probability of flipping heads is 1/2. Okay? So, if I think about this, I'm going to use this random, and so I'm going to flip a coin 10 times, and I'm going to select my type of coin. I'll go with a US penny, and then I'll flip the coin, and then it will tell me that I have one, head, tail. Uh-oh. 1, 2, 3. 1, 2, 3, 4, and then 6. Okay. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. All right. And so the experimental probability of flipping heads was 4 out of 10. And so the percent error then, so I've got my tally marks, I've got that, and then if I remember correctly from the other day, or from earlier today, I need to take the experimental probability. So I need to take the experimental probability, which is 4/10. I'm going to subtract the theoretical probability. So I'm going to subtract 5/10. I'm going to put that whole thing over 5/10. Okay. And when I do that, I'm going to get, that's going to be the same as -1/10 divided by 5/10. And I can write that a different way. This is a complex fraction, but I could write this as -1/10 divided by 5/10. And that is the same as taking -1/10 times 10 over 5. I would reduce first, then I would multiply, and I would get a percent error. So I times that by 100. 1/5 times 100 would be -20%. So my experimental probability was 20% below what the theoretical probability would be. Okay. Then it says combine your results with a partner. Okay. So describe how the experimental probability, theoretical probability, and percent error changed. Okay. So if I was doing this with a partner, then I would have another group of 10. Whoa. Oh, that's cool. All right. And so 1, 2, 3, 4, 5, 6, 7, 8, 9 tails. I've never seen that before. So my partner had 9 tails and 1 head, and I had 4. So it would be 5 out of 20. So it went way down with another group there. All right. And then the theoretical probability is going to always stay the same. Then the percent error is going to get way worse. And so now we would have, let's see here, the experimental 5 over 20 minus the theoretical 5 over 10. Oh, sorry, 10 over 20. I'm trying to get a common denominator. Divide that by 10 over 20. And 5 over 20 minus 10 over 20 is going to be -5 over 20 all over 10 over 20. That's going to be 5 over 20 times 20 over 10. And that's going to be -1/2 times 100 is going to be -50%. So 50% below. So it got worse. Okay. Now let's say if we did like a whole class, and like let's make this really easy now. So if I did a whole class of this and I wanted to like really think this through, let's just say I started over again and I made it so we did this 100 times, because that's an easy number to work with. And then I'm going to flip the coin again. Oh no. Except this is going to be tricky. Does it tell me my answer? Why would it tell me my answer? That would be too easy. Aw. All right. Counting. All right. I'm going to count the number of heads here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44. Okay. So now we have 44 out of 100 for our experimental probability. We're subtracting our theoretical, which would be 50 over 100, and that's all over 50 over 100. And then that would be the same as 6 over 100, negative 6 over 100, all divided by 50 over 100. Oops, sorry. And so I take the experimental minus the theoretical, then I put it over the theoretical. This is a complex fraction, which is like a crazy division problem. Negative 6/100ths times 100 over 50. Keep change, flip, not KFC, KCF. Reduces down, 3 over 25. And so this would be equal to negative 3 over 25. And I would times that by 100 because that's the rest of the thing. And once I do that, I take 3 divided by 25 times 100. And I get negative 12%. Okay. And so what should seem to happen, at least it kind of did. Those are weird results. And that's going to happen sometimes where you have really strange results. But normally we would have higher error and the error should go down. And the error was going down. And I bet if I did 1,000, I bet you it would be much closer to 50% even. Okay. And if I did a million, I bet you'd be really, really close to 50%. And so as you do more experiments, it tends to get closer to the theoretical probability. So it did go down. And I would say it goes down because I'd say it goes down because theoretically is like if you do a whole bunch of trials, it gets closer and closer and closer to that. That's all I got for right now. Okay, so that was activity 3.4. Yeah.